This will be my last video as far as the very beginning algebra students formula solutions here. And really this one probably belongs in the next channel, but the way my granddaughter is moving through her algebra class, I think I better put this in because I think our teacher is going to be getting there very quickly. And this example is deriving the quadratic formula. And so what we're going to do is we're going to solve the equation ax squared plus bx plus c equals 0. And we're going to solve for x. What I'm going to do next is open up wx maxima, and I'm going to solve for that problem in my buffer. So I'll just click there, ax, and remember wx maxima, it does not understand implicit multiplication, so we have to make sure we have all the multiplications available there. Put that in, and we're going to solve for x. Click OK, and that's how quickly wx maxima solves this problem. And I'm going to leave that in place there because that is the solution. Now then, we're going to go the pencil and paper route. I'm going to show you how you derive that formula pencil and paper style. So our equation is ax squared plus bx plus c equals 0, and we want to solve for x. So before we even start here, I'm going to tell you we're working on a second degree polynomial because we have this x squared up here. And anytime you see an x squared, constants and so forth, that is called a second degree polynomial. So we're going to work to solve for x, and the only way we're going to be able to do that is we're going to complete the square of this equation. So we're going to prepare to do that. We're going to put c divided by a on the right side of the equation. So we just subtract c over a on this side, and we subtract c over a on this side, and this is what we get right there. Now then, we're going to complete the square. And trust me, you'll learn to do this with your eyes shut later on, because you're going to be doing this a gazillion times before you get through high school physics and college physics. You'll be completing the squares umpteen times. All you do is simply take the bx term right here, divide it by 2, and then square the result. And that trick works on everything, all second degree polynomials, to complete the square. So we're going to add b over 2a squared to both sides of the equation to complete the square here, and this is what we get. Now then, we're going to complete the square, and all you do is just factor this term over here on the left side, and you have x plus b over 2a, and that entire quantity squared is equal to c over a minus b over 2a quantity squared. Take the square root of both sides. Look what's happening. Our dependent variable x, we've got it isolated. We almost have the problem solved. So we got x plus b over 2a is equal to the square root of this mess right here. So now then, all we have to do is move b over 2a to the right side of the equation, and we have x isolated. And like I said, the equation is solved right now, but it's kind of hard to use the way it stands right here. We'd have an awful lot of substitutions to make if we were going to use this formula like you're going to be using it in the future. So now then, we almost have common denominators all the way across here, if you notice. We have 2a here, and we have 2a squared. So if we take the square root of that, it'd be 2a, so we have a 2a there. But over here, we just have a c over a. So we need to do something with this in order to get this, or this denominator, when we take the square root of it, to be 2a. And the way we can do that is just simply multiply c over a times 4a over 4a, which is 1. But look what happens as we perform this task. We simplify it, and we get b over 2a plus or minus the square root of this term, 4a squared, plus b squared over 4a squared. And now then, when we take the square root of 4a and 4a squared and 4a squared, we have with common denominators across the board. And we can really simplify this equation. So we're going to take the square roots of the 4a squared, and we're left with this line right here. Minus b over 2a plus or minus the square root of minus 4ac plus b squared all over 2a. But since we have common denominator here, we can take the next step. We're going to use the community process to flop this b squared 4ac and put it like we're used to seeing the quadratic formula, b squared minus 4ac instead of minus 4ac plus b squared. We had just one more step to do before we solve it. All we had to do is combine terms, and we are absolutely done. So now then, when we combine terms, we get minus b plus or minus the square root of b squared minus 4ac. All that is over 2a, and we have solved the quadratic formula, and that's all there is to it. C over a